conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. We begin our event with this beautiful slogan, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amridam Gamaya, praying to the Almighty to lead us from ignorance to truth, from darkness to light, and from death to immortality. Let me welcome our dignitaries onto this virtual dais. We have with us Professor Jay Maiti, who is the chairman of the center, Professor O.B. Krishna, who is the convener of the weekend talk, and our expert speaker for the day, Dr. Kranti Raditya Dalmahapatra. He is currently working as the assistant professor in Tyagaraja School of Management, Madurai, Tamil Nadu. He obtained his PhD from the Department of Industrial and Systems Engineering, IIT Kharagpur, with 6 years of experience focused on bridging the gap between the rapidly advancing technological developments and the safety management systems of organizations through integration, analytics, and virtual reality. He obtained his BTech and MTech in Mechanical Engineering and Production Engineering from Institute of Technical Education and Research, Bhubaneswar, and Veer Surendra Sai University of Technology, Odisha, respectively. His research areas include data analytics, machine learning, virtual reality, operations management, and multi-criteria decision-making. He has published research articles in reputed journals such as Safety Science, Computers and Industrial Engineering, Reliability Engineering and System Safety, Applied Soft Computing, etc. He has served as reviewer in several journals such as Interactive Learning Environments, Safety Science, Virtual Reality, and Intelligent Hardware. CASCA wholeheartedly welcome you to this event, sir. A very privileged to attend to. Now I kindly invite Professor Jay Maiti to formally welcome our expert speaker. Over to you, sir.
Thank you, Swin. Thank you, Dr. Krantiraditya Dhalmahapatra, for accepting our request and giving it, going to deliver one of the very, very important as well as emerging topics in safety engineering and management, that data analytics and virtual reality application in the prevention of accidents, injuries in workplace. Dr. Dhalmahapatra did his PhD under me in the Department of Industrial and Systems Engineering, and he is the first. He is one of the first research scholars from our safety analytics and virtual reality lab. And as you know that this particular domain is, although it is very emerging, but it's understanding this domain and using it in the safety engineering and management application point of view, it's a very difficult task. Initially, what Kranti has said, and in a lot of extra work, and I can say dedication and devotion, finally from him finally made it possible that yes, we will be able to develop something like EOT crane virtual reality simulator, which was verified by operators, EOT crane operators from large industries, and sufficient training was also given to them, and all appreciated the work. So that is what I can tell that Dr. Kranti's that USP, unique selling point. He knows virtual reality. He knows how to apply it in the domain of accident analysis, accident prevention, safety management, safety engineering. In addition, data analytics is another area, and actually Swin has already mentioned these publications in the reputed journals, including Safety Science, Computers and Industrial Engineering, Reliability Engineering and System Safety. And yes, we are missing him because of for the virtual reality application development point of view. So I am sure that Kranti will be in touch with our present project staff and other research scholars, as well as with all of us, so that the development what has been started with him, it will continue, and in the long run, the industry as well as academia and society will be immensely benefited out of it. So I request Kranti to that keep this in your mind. Second, that COE was established recently. Maybe I think it is around 1.5 years old, and you by that time you probably left this institute. And COE wants your help and cooperation. And the participants, I'm sure that you will be really enjoying today's presentation given by Dr. Krantiraditya. And you have seen in the title itself, the novelty is very much there. As the title is very broad, it will not be possible for him to tell the nitty-gritty of everything, but I'm sure you will be getting a lot. There will be a huge take home for all of you today. With this, I welcome all the participants, as well as I welcome Dr. Krantiraditya Dholmahapatra to give your expert talk on this very important topic. Dr. Krantiraditya.
Thank you so much. Sir, can I start, sir?
Yes, you start.
Yes, sir. First of all, thank you very much, sir, for inviting me for this lecture. As your student, for the first time, I'm getting an opportunity to present in the IIT Kharagpur, such a big platform. So that is a huge opportunity, like huge thing for me. And I'm like always told, like I'm always telling everyone that I'm missing the mentorship of yours and Krishna, sir, because whenever I need something regarding whatever problem I faced during my PhD, I always seek your guidance, and that I got. So, like you said, I will be in touch with you. You know that I'm continuously like in touch with you, and I'm asking you so many things which I should not ask after PhD, but I will keep on asking because I will not stop that because I think I deserve that, sir. So, with that note, sir, with your kind permission, so I would like to share my PPT, and I will start. And I hope everyone will enjoy today's presentation. Like you said, sir, the topic is very broad, but I will try to summarize each and every aspect so that it will be like for a layman also, it will be very, very easy. And for each and every person who doesn't know anything about data analytics and virtual reality, it will be easy for them to understand and how exactly to proceed. So let me share the PPT. So my PPT is visible, sir?
Visible.
Yes. So my topic for this talk is we can talk on safety engineering management and analytics is application of data analytics and virtual reality for accident causation and prevention. Myself, Dr. Krantiraditya Dharmapatra. I'm working as an assistant professor on operations and analytics team in Tyagaraja School of Management, Madurai. First, starting with what exactly is, why exactly we are talking about this safety, because everything we are uh, dealing with this weekend talks is all about safety, how to achieve excellence in safety and all. So first, starting with safety is integral to success. So safety is a key component for any organization that wants to have a sustainable and profitable operation. So, like that, injuries to employees and breaching to any environment also harm the reputation of the company that everyone knows, and how exactly this individual will be affected, and that is going to affect their family members, and subsequently the organizations has to pay for that. So, each and every aspect is very, very important in this nowadays in terms of safety and all. That's why each and every organizations are following certain principles that are zero injuries, zero occupational illness, and zero environmental accidents. So consequently, it can be told as 100% safety, 100% safety environment. So moving ahead, so
Kranti, can you put on your video?
yes, sir. My video is not visible.
If it's not working, it's okay. Otherwise, if it is
No, my video is on, sir. So should I switch off my video or should I
switch on.
So it is switch on, sir.
Why it's not coming your photo?
Let me try again, sir. Is it visible now?
Yeah, I am able to see you.
Yes, sir.
I am able to see you. So maybe other Sovik, are you able to see?
Yes, sir. But now again the video is
Now
off.
again it has gone. It has gone now.
Hmm.
Uh,
I think some network issue is there.
no, actually, sir, Webex is having some problem. I don't know. Some problem is going on with Webex. Like yesterday, also same thing happened, but I don't
Okay,
know, sir.
Kranti, go ahead. Go ahead. Don't worry.
Yes, sir. PPT was visible. Yes, sir.
Yes, yes, PPT visible.
Yeah. Now I hope PPT is visible to everyone.
Yes, PPT
Yes,
visible.
Yeah. Yeah. So the second topic I want to focus is on accidents are tip of icebergs. So why exactly this thing is important? Suppose like why exactly this Titanic incident happened? Because they were not knowing that, because from distance it was visible that there is a small iceberg that is seen, but inside that a huge iceberg there, it was not visible to anyone. So similarly, what exactly is happening? Everyone is seeing that iceberg accident as a tip, but they are not knowing that what exactly is leading those accidents to happen. So starting from the bottom, you can say that deviation from the standard practices and environments. Then at risk behavior, what are the risky behavior that is being shown by the workers at the workplace? That is the second causes. Because of this risk behavior, what kind of unsafe practices and what kind of unsafe conditions are arising at the workplace? That is the third thing. Then sometimes what is happening, near misses are happening because of this kind of unsafe practices and conditions, and finally it is leading to accident. But what we are seeing only accidents. We don't know that, or we are not seeing that these are the step by step events that is actually leading to accidents. So everybody is thinking that accident is happening, it's a normal thing that will happen and we can ignore it. But because of, for every injury in the absence from work, there are 10 minor injuries, and there are 30 material damages, and there are 600 near misses. That means for each injury, this is the statistic that is we are
So
having like 10. Yes, sir.
your slide is static, so and it is not in PPT mode, I think. We are seeing the first slide where the safety is integral to success, that one.
It is
Now it is in PPT mode. You are visible also. Go to your PPT. Your
sir, now
PPT is,
is it
no,
visible
no,
now?
PPT is not coming. Earlier
Is it
your PPT was there, but it was not in PowerPoint mode. Now it's
sir,
fine. Oh,
is
oh,
it come?
again it has gone back.
No, it
Go
is
to slideshow. Go to slideshow mode. Yes, it is okay.
so now it is okay, sir. Is
Yeah,
it
it is okay. It is okay.
okay? So for each and every injury is resulting in an absence from work, then consequently there are 10 minor injuries, 30 material damages, and 600 near misses. So the reasons I explained because of which these accidents are happening. Because of that reason, we are actually we should not ignore those kind of particular reason, and we should not let this accident to happen. That's why it is written here that in the future, less of this means less of this. That means less of near miss, less of unsafe practices, less of at-risk behavior, less of deviation from standard operating procedures, standard operating practices and environments. The less of accidents will happen. So that is what is accidents are tip of the icebergs, which should be considered as a important event for us. Then moving ahead, why exactly is it my PPT is visible? Yes, safety informatics PPT is visible to everyone. Sovik, Sween.
No, no, no.
yes.
It is not changed. It is now in the accident iceberg PPT.
Okay,
In
sir.
the previous slide itself,
Sween,
sir.
Sween, you start presenting.
Yeah, Sween, we can start the start presenting. Yeah,
Okay.
you go to the third slide. I am stop sharing. I'm stopping sharing. Yeah.
Is it visible?
Yes. Yes. Third slide. Yes. Thank you.
Okay. This one?
Yes. Yes. So third most important thing is safety informatics. Like why exactly safety informatics is coming is because we are getting plenty of accident data, plenty of incident data, plenty of near miss data we are getting. But how to deal with these data? So that's why initially people used to say that it is data analytics we can do, and like the data analytics, the virtual reality, the technological aspect, whatever it is there, that thing is summarized and we are telling it as safety informatics. So safety is a central dimension in contemporary debates on human health, loss prevention, environmental protection, sustainability, and cleaner production. In the information age, especially in the era of big data, safety information is essential strategy for safety. That means big data, we are actually generating huge amount of data with respect to this accident, incident, and all. So how exactly from those data we will extract the important information, and from those important information, what exactly we can do? Like we can identify some of the preventive strategies so that this kind of accident can be prevented at the workplace. So this scientific discipline actually deals with safety information and its movement laws. Now, what exactly the movement laws are? So when exactly one accident is happening, it is not exactly happening randomly. It is happening because of certain events that led to that accident. That means certain events created that movement to cause that accident. That's why it is some information is there, but how exactly that movement laws are creating or indicating, like how exactly it is indicating for the final event, that is the accident. So it is the purpose to address the problem of lack of safety information in the safety management domain. Why exactly safety informatics we are telling? Because initially there are earth informatics, medical informatics, material informatics, molecular informatics, and bioinformatics. Even mining informatics is also there. That's why when we are dealing with big data in safety domain, that's why the name is a coin is like the term is coined as safety informatics. Next, Swin. Swin, can you? Yeah. So the if we will talk about this development of safety informatics, how exactly the safety informatics is how exactly the evolution happened in the safety informatics and all. It started with I will try to explain the safety informatics with reference to industry 1.0 to industry 5.0, safety 1.0 to safety 5.0. So what exactly happened is like industry 1.0. Industry 1.0, it actually started with mechanization of steam power, which is actually the first mechanical loom spinning in Jenny in 1784. It was used. So it was actually having experience-based safety science. That means what? Suppose there is some safety issues are there. Whomsoever is concerned person there who was working with the machines and all, out of their experience, they will say that this should be the safety measures that should be taken into consideration. What is the key takeaway from the industry 1.0? That is safety experience. So let's move on to industry 2.0. What happened is in industry 2.0, electrification through electrical energy. That means previously electrical energy was not there. So electrical energy came into the picture. First assembly line started in Cincinnati slaughterhouse in 1870. There, what exactly came into the picture? Technology based safety science that came into the picture. So safety was taken into consideration, safety thing when it is coming. So some of the technological stuff came into the picture so that safety can be achieved. So that's why the key takeaway from the industry 2.0 is safety technologies. Now let's move to the third part, that is industry 3.0. What happened in industry 3.0 is computerization and automation through computers and electronics. That means some robotic arms came into the picture, some programmable logic controller PLC that came into the picture in 1969. In this particular phase, safety 3.0 came into the picture, where system safety science was the important part, and system safety theories and methods came into the picture. System safety theories like stamp model, like different accident causation model, HFACS model. This kind of model actually came into the picture to solve the safety related issues. So simply we can understand that we have to analyze the system with respect to some of the safety related theories. Those safety related theories are being coined by or are being proposed by some of the safety pioneers in the beginning of 21st century. So that's why Industry 3.0 and Industry 4.0 is there, and the key takeaways from the Industry 4.0 or Industry 3.0 is system safety theories and the methods. Now let's move on to Industry 4.0. In Industry 4.0, what exactly is happening? Intellectualization through cyber physical system and the Internet of Things and the network. So cyber physical system came into the picture. How exactly we can track each and every physical system through cloud-based network. That actually came into the picture, and here computational safety science came into the picture. Like computational, like with using some computational safety methods and all, we will achieve the safety excellence and all. So safety 4.0, the key takeaway is safety informatics or computational safety science. Now, as today academician and safety practitioners have joined, I'm opening this for everyone that what exactly should be Industry 5.0 and what exactly should be Safety 5.0. Now Industry 5.0 is coming up, like it will be in the pictures in some days. So what should be the Safety 5.0 and what should be the Industry 5.0? That we can discuss like in future scope and all. Yeah, next. Swin, yeah. Yes. So next is Industry 4.0. In Industry 4.0, I explained everything, like how exactly from evolution is happening from Industry 1.0 to Industry 4.0. Why exactly I want to focus in Industry 4.0? As the title suggests, data analytics and VR based accident causation and prevention. So where exactly this data analytics and VR is coming? They're coming from the Industry 4.0. Why exactly I showed the safety informatics? Because I wanted to tell you that safety informatics is the evolution started from Industry 1.0. Now we are reached to Industry 4.0. Each and every techniques we are using for achieving the safety excellence and all. So some of the technologies are being used in this Industry 4.0 are eye tracking, virtual reality, augmented reality, cloud computing, cyber security, big data, Internet of Things, additive manufacturing, autonomous robots and all. So some of the areas are very like fascinating areas nowadays, like in eye tracking also. Some of the industries, like one or two example I will give. Eye tracking, I have seen recently in some of the industry how this eye tracking is being used. Suppose one worker is coming to workplace, uh, like he is not in a he's fatigue, like he's having fatigue, he's not in a proper mental condition, or he's having stress to go for the work and all. Simply we can use some eye tracking based system, and we can see that whether he is having some fatigue and also fatigue test we can do with respect to eye tracking or not. So VR and AR I'm going to discuss detail in this. So other things like autonomous robots, additive manufacturing, Internet of Things, big data, and cyber security and cloud computing actually constitute this Industry 4.0. Can you go to the next slide?
Hello, Dr. Kranti. The
Yes.
slides, Swin, slides are not visible.
It's not visible, sir?
Visible in the sense very blurred. The words, nothing is readable.
Okay.
Is it because of your system, or I don't know? Because but when Kranti was
No,
presenting,
no,
that
I'm
thing
not.
was visible.
Yeah. Yes, sir. Now I'm not sharing because of this issue that you told. That's
So, Vic, sir, can you share it then from your side, sir?
Okay, I'm sharing.
now it is visible. Yeah, so we can go to the accident causes and model slide.
Yes, I'm here. Here only.
So accident causes and slide is being shown to everyone.
Yes. That slide is shown.
No, not shown.
Not
Uh,
shown. So
Sir,
You do one
we have
thing,
seen
that
the first
enable
slide.
editing you do, and then
you click on that enable editing. After that, you go to slide.
Okay. Now I think now Ashish, I think it is okay.
Yes, it's okay.
Yes, now it is visible.
Okay, go ahead.
Okay, so as the topic suggested, the accident causation, like application of data analytics and virtual reality for accident causation and accident prevention. So why exactly, how exactly we are going to study this accident causation? There are several accident causation models that has been proposed in the past. One with respect to, we can divide it into two parts. One is like static accident causation model. Second is dynamic accident causation model. So what exactly is static accident causation model? Static accident causation models deals with time, like the time is constant in one particular time. You can find out that how the accident happened, what are the events led to that accident, and we can analyze further. And in dynamic accident, it's a time independent accident causation model. So with respect to any time t0 to t is equal to t, you can analyze all the accident, how exactly that accident propagated, and you can take up the data and you can analyze. So in the static accident causation model, we further it is bifurcated into traditional approaches and current practices. So in the traditional approaches, accident proneness theories were there, where exactly it is told that some of the people are prone to accidents. Like they whenever they are working at the workplace, they are prone to accident. Then second is dominoes theory. That means some of the incidents are leading to accidents. So dominoes theory suggests that sequence of events, how exactly it is leading to accident. Then it came to epidemiological theory, when through some graphical displays or graphical displays of events, how exactly that accident happened. So that exactly is saying the epidemiological theory. Then finally, human factor models, like how exactly the ergonomic behavior, how exactly the human is behaving at the workplace. That kind of studies are actually carried out in the human factor models. Then when we came to the current practices, some of the theories like fault tree analysis, Monte Carlo simulation, failure mode effect analysis, and hazard and operability studies are there, which actually help for this accident causation and all. Then when we are coming for this dynamic accident causation model, the static version of fault tree analysis, Monte Carlo simulation, and HAZOP is actually taken into consideration, and time independent nature actually is put into that, and dynamic thing actually taken into consideration. Then we are coming to 3D modeling and simulation. When we are talking about 3D modeling and simulation, we are not talking about virtual reality. Normally, one person can see the 3D modeling, can do the 3D modeling in any high-end workstation, and they can do the simulation, and they can tell that whatever ways these accidents are happening. Whenever we are seeing whenever one train accident is happening, all the news channels are what exactly they're doing. They're doing the simulation. They're showing the simulation model in the news channel. That means how exactly they did it. They created the 3D models of the train. They created the 3D models or avatars of this human beings, and they're simulating it, and they're showing it how exactly this 3D modeling and simulation is helping us to know how exactly accident happened. But what is actually differentiating the VR from the 3D modeling and simulation? So VR is giving you the edge in terms of immersivity and interactivity. What exactly is happening? Suppose one user wants to know how exactly incident happened, so he can physically, like he can virtually go to that place instead of going physically. He can virtually go to that place, see the things in the simulation phase, interact with the objects, why exactly it happened, how exactly it happened, what went wrong. This interactivity and immersivity will give you the edge in virtual reality. That is what the advantage virtual reality will give you in terms of this modeling and simulation. Can you go to the next slide? Yes, Sobi. Yes. So what are the issues that need to be focused then? Why exactly I will do this accident causation and prevention? Why exactly I'm talking about this data analytics? Why exactly I'm talking about this virtual reality? Why I should merge both data analytics and virtual reality and give some solution? Because some of the issues that we found is, one is data analytics based approaches are not addressed in any of the traditional accident causation researches. Then hazard identification and risk assessment are purely based on workplace inspection and incident investigation. Use of modern technologies were not there. Then safety by design is still dependent on experts' knowledge, primarily experience and intuition based. That means whatever experience I'm having, because like I have worked in this workplace for 10 years or 15 years. So I can tell that you do this thing, that is a safe behavior. And I can tell you out of my intuition, nothing will happen. You can do this work. So that primarily it was happening because of primarily experience and intuition based, coupled by some risk assessment process that is known to that particular expert. So experimental results are not there, which can be done with respect to the VR. How it will be done, I will tell you in the next slides. So safety training, for the final one is safety trainings. So safety training is given to the workers till date are either classroom based or on the job based or both. But this has limited the effectiveness of the worker in terms of hazard identification and avoidance. So just imagine one thing. Recently, like 2-3 years back, one of the coaching institute caught fire in Surat, Gujarat, Surat. So some of the fire workers went there, they tried to save the students from that particular building. But what exactly happened? The fire workers came and they saw that the fire actually is on the third floor, and the fire workers are not sufficiently trained so that they know that how exactly the ladder will be put for the third floor and how exactly they can go to the third floor and save the people. What exactly happened? Then the students jumped from the third floor. Some of the students got saved and some of the students died. What exactly is the problem here then? They are not, these fire workers are not properly trained how to save the people at any emergency situation, this kind of emergency situation. Why they are not trained? Because they may not be having this kind of interactive or immersive situation. Suppose I can create a fire situation and I can subject all the fire workers to this kind of fire situation. You go and get trained and tell that how exactly you will save the people who, when actually real fire will break out. So that kind of training is not there. It is either classroom based or on the job based. On the job means they will tell you that this is the situation, this kind of situation will happen, and how exactly you tackle this kind of situation. But actual like experiencing the accident situations in a real time is not there. That's why these issues are there in the accident causation approaches previously. That's why the data analytics based and virtual reality based virtual reality based techniques has to be incorporated so that we can address these issues. Yeah, so witness. So for starting with data analytics, so this is a normal safety roadmap for safety data analytics. So first we will start with data preparation, then second we can go for analysis, and third we can go for decision making. So I will not go through that much detail for this data analytics part and all the nitty-gritty of these techniques and all. So what I can say is like when you are having one accident data and all, you can have that data into raw data you will get. Then you will go for data cleaning and formatting. That means you will process the data and then you can start your analysis by writing some codes. You can do predictive analytics, you can do some descriptive analytics. Predictive means you can predict that when exactly this this kind of incidents are going to happen. Some of the forecasting techniques are there, you can use this. And descriptive techniques means you can use some bar chart, pie chart, then you can use some cause effect diagram and say that what are the causes behind this kind of incidents. What exactly is the deviation from the standard operating procedure that happened that day? Because of that, these incidents are happening. And you can find out your analysis reports. And these analysis reports can help you to find out what kind of preventive strategies you can deploy at the workplace so that the accidents that happen today can be prevented in the future. So these preventive strategies also we can identify in the decision making phases. So the safety data analytics actually deals with three kinds of things. First, you will get the raw data, process the data, then the processed data can be analyzed with respect to predictive and descriptive, and preventive prescriptive analytics can go for some identifying some preventive strategies and all. Yeah, next. So why exactly then VR and AR technology? Data analytics part briefly explain. What exactly will come in this VR and AR technology? It's a learning platform. So why exactly VR and AR came into the picture? Limited learning horizon, absence of real-time experience, expensiveness with respect to traditional practices, low level of user engagement, failure on safety knowledge retention over the period of time. So first is like learning horizon, like they cannot know each and everything at the real workplace. If you are not at the training center, they cannot know each and everything. If I will give them the view of exact workplace where exactly they are going to work, so each and every component they can see. Then what they can do, what is the problem with this component, where the component is exactly placed, what is the design issue, what is the maintenance issue, what is the operation issue. This kind of thing I can identify with respect to virtual reality based modeling and simulation. That is not possible in traditional way, traditional method. That's why it is limited learning horizon. Then absence of real-time experience, that's what I told, like interactive and immersiveness will be not there in any traditional training practices and all. Then expensiveness, how exactly you can like you can spend some financial issue, look after some financial issues when it is coming to this virtual reality environment only, because it's a one-time investment. Once you created the platform, once you created the lab, once you created the setup, it can go on for many n number of safety trainings and all. Then low level of user engagement, when you are training the users with respect to some bookish knowledge and all, the problem will happen is like they will get bored of this kind of bookish knowledge and reports. They will not read the reports and all. What we can do, engage the user with respect to some simulation stuff, where exactly what exactly will happen. They will get interest for this. Okay, this is the safety, this is how I am going to use this equipment, this is how I should follow the safety protocols and all. So that is this low level of user engagement can be overcome with the virtual reality thing. Then failure in safety knowledge retention over the period of time. That means when you are teaching the safety knowledge to uh, practitioners or any workers at the workplace, what is happening over the period of time, that knowledge will be vanished. It's experimentally proved that when VR based training is given to workers, they are retaining this knowledge for a longer period of time. And when they are having the same knowledge in traditional working practices and all, it is like they are forgetting in a longer period of time and all. So it's an experimentally proved fact and all. So VR AR-based training has given a platform to develop perceptual experience and cognitive ability for problem solving and decision making under complex situation without exposing personnel to real-time hazardous or environmental conditions. That means what? Suppose I'm having a workplace where I'm dealing with a machineries which is having 1200 tons molten metal. That means this molten metal must be having temperature of 1500 degrees Celsius, and 1200 ton is a huge amount to handle with. So when I'm training the personnel without exposing the personnel directly to the this kind of situation, what I can do, I can I can create the same kind of environment in a lab setup. Then I can train them, this is the way you should handle this kind of situation. You can identify the hazard, you know how to how to operate this thing further and all. So without exposing the personnel to real-time hazardous condition, we can train the personnel in the lab environment and all. Then application of VR and AR in safety domain is significant, specifically for hazard identification and risk perception, situational awareness, and cognitive study. So one of the experiment we did in the lab at IIT Kharagpur, we found out that when they are identifying the hazard with respect to, like, we asked them that what are the hazards at the workplace. So they identified these are the hazards we can identify at the workplace easily. Then we gave them a training in the virtual reality environment and all, and we found out that the hazard improvement index is more than 0.6. That means what? After VR based training, they're identifying the hazard more easily, and additional hazards also they're identifying, and they're telling by themselves that this is the way these hazards can propagate to accidents. So this kind of benefit we can get when we are actually deploying this VR and AR based techniques in safety domain for hazard identification and risk perception. Yeah, so Vic, next. So this is one of the adapted from Lee et al. 2018. How exactly VR and AR are actually getting like how exactly applications are happening in safety domain, like hazard identification, then risk perception, then situational awareness and cognitive studies, then safety education and training, safety inspection and instruction. So how exactly safety is enhancing? What exactly safety enhancement mechanisms are? So working environment is getting enhanced, then workers' behavior, high risk equipment, like how to handle with how to tackle with high risk equipment, but what should be the work sequence that should be followed. So this enhancement mechanism also can be achieved with respect to VR and AR. Then what is the evaluation procedure? How exactly I will evaluate that whether the operators those are getting trained at the workplace, they're actually understanding the thing and all. So some subjective assessment and evaluations are there, and objective assessment and evaluation methods are there. So these are the ways VR AR can be taken into consideration when we are talking about safety and all. Yeah, next. Yes. So finally, I showed you one in the previous slide that how exactly data analytics roadmap for the data analytics can happen. Then how exactly this traditional model can be transformed in such a way that the problem or the drawbacks that we were having in the traditional accident causation model that can be overcome with respect to virtual reality. That's why it is safety ideology mapping of virtual reality. So in the traditional model, what was there? Complex operation consists of some hazardous elements, which is initiated by some initiating mechanism, which is causing accidents, which could have prevented by some preventive risk control system. Like before accident, we could have we can place some preventive risk control system that is called as PRCS. Then these accidents are affecting whom? Target or threat. Who are the target? People, property, and environment. What is the threat? Threat is like injury, property damage, some environmental release, some fire breakout. This kind of threat can happen. So after accidents, what we can keep? We can keep some mitigating risk control system. What are the mitigating risk control system example? Like some first aids, some ambulance, some emergency responsive systems. So those can be some mitigating risk control systems. So how exactly VR can come into this picture and all. So this complex operation can be handled in VR by doing some 3D modeling and simulation and creation of virtual workplace environment for that particular complex operation. So for that, what we have to do? Some planned visits, expert demonstration, then we can collect some 2D drawings, photos, and videos. And this can be converted into, this can be used for creating the 3D modeling and simulation in virtual workplace environment. So we address the complex operation thing with respect to one particular domain in VR model, that is creation of 3D modeling and simulation. Then what exactly will happen for this hazard elements and initiating mechanism? So we can train the train the operators or train the users using two methods. One is desktop based VR, second is head mounted display based VR, that is called as HMD VR. So what is the advantage or disadvantage in this? So VR, like nowadays VR can be experiment are happening in two ways. Desktop based VR is also going on and HMD based VR is also going on. When we did the experiment in two ways, so that we can check that which is effective, and we found that the head mounted display based VR is effective. Why? Because from the since the beginning I'm telling that the advantage of VR is immersiveness and interactiveness. If I'm like giving the real I'm subjecting the user to the real experience, I'm giving the user the real experience, then they will identify the hazard in a better manner. What is then the desktop VR? The desktop VR is you can identify all the things. The modeling and simulation will be done, and that will be the simulation will happen, and you can see that in this way this accidents are happening and what are the hazards you can identify. So desktop VR will identify, or desktop VR will help for that. So desktop VR and HMD VR, which will help for hazard identification, creation of events leading to accidents, then visualization of possible accident scenarios. So why exactly it is written creation of events leading to accident? That means what? We can identify the events leading to accidents in a traditional method, but can we create the events leading to accidents in a traditional method? No. What we can do, what kind of events that led to accident? It may so happen that this kind of event is leading to accident 1. Similar kind of events may lead to accident 2 or accident 3 or accident n. How to create those kind of environments, or how to create that kind of accident scenarios? Identify the events, create those events in the virtual environment, create possible accident scenarios. That means what? If one accident is happening, you can train the operators with same kind of events for 5 kinds of accident scenarios. That is the advantage you will get in VR-based training or VR-based accident causation modeling and all. So you can create different kinds of accident scenarios with respect to some of the events that led to accidents. So finally, you can realize the fatality, injury, property, and property damage and all. So how exactly you can find out this hazard identification? So you can create some hazard list with respect to design knowledge, incident data that we are having, then expert knowledge, then safety analytics, then initiating mechanism list also we can prepare. and accident scenarios list also we can prepare. Now the question is, how exactly this list of hazard, initiating mechanism, and accident scenarios will be prepared? It can be prepared with respect to design knowledge, incident data, and expert knowledge. That means incident data is coming into the picture. Safety analytics is coming into the picture. So what exactly is happening? Now we are coupling this data analytics knowledge in the VR model. That's why from the beginning, like the title suggests, like title is designed in such a way that data analytics and virtual reality for accident causation and accident prevention. So once this data analytics will come here, then we can identify the hazards, identify the events, identify the possible accident scenarios, create the possible accident scenarios, and what kind of preventive strategies we can follow at the workplace so that this kind of accident can be removed. Yeah, next, Sovik. So these are some of the VR and AR applications for the safety training that is going on nowadays. Healthcare, you can see one of the doctors, they are performing some robotic surgery. With respect to VR and AR, like those are some polyphemus arm they're using in healthcare sectors. Then you can see underground coal mining means there are some places in the underground coal mines and all where if a worker is going directly, he will be not, if he is not knowing what exactly he is going to face in the underground situation and all, so it will be a trouble for him. So some fatalities or some accidents may happen. So what we can do, we can create the underground coal mining scenarios from beforehand, train the operators there, then send the operators go and see how exactly it is happening. So these people are trained beforehand and then sent to the underground coal mines and all. Then in process industry, the people are getting trained also. In steel industries and other construction industries also, these people are getting trained. Construction industries is also here. Then finally, ergonomics in assembly. Like I told in one of the model that one of the accident causation model is human factor models. So how exactly this person is actually behaving with respect to his body posture, with respect to his head posture, each and everything, like head, elbow, wrist, how exactly his movement should be, each and everything can be studied with respect to virtual reality based environment. So these are some of the applications in training. Yeah, next, sorry. So what will be the benefits for the safety practitioners then? So I have segmented into two parts. One is industry, one is academic. As this forum is both open for industry and academics. So for the industry people, industry persons or industry practitioners, what will happen? Recognition of hazardous energy, hazard avoidance, how to perceive the risk perception, strategic approach for accident prevention, what kind of strategy can be adopted. The risk-free VR training for skill improvement. That means the VR training platform that we are using should be risk-free for them. They can come, they can get trained, and they can go to their workplace and do the normal work and all. So for the academic side, what exactly is happening? We can extensively study that. What exactly, how exactly improvement can be done in the accident causation modeling and all. How exactly situational awareness study improvement can be done and all. Then cognitive and ergonomic studies, the safety assessment and evaluation, and finally the design of man-machine interface. So some of the issues are still there when we are designing the man-machine interface in the virtual reality environment, which issues still like those are yet to overcome that we can address with respect to academics and all. Yeah, next, Sobi. So finally, I'm presenting one combinatory approach. So these are already like published by our side and all. So this combinatory approach is like as we are talking about data analytics and virtual reality. First, I have shown a model where exactly we are showing that data analytics based DSS. That means data analytics based decision support system. Second part, we are showing accident causation modeling. Third part, we are showing safety training simulator. So it is the safety training simulator is the accident prevention. So accident causation, accident prevention, virtual reality in the second part, then data analytics. So what exactly will happen here? Incident data can be collected. I have mentioned categorical and numerical. We are open to work with text data also. So some exploratory and causal pattern analysis we can do. Then use some data mining and statistical techniques and identify some significant rules for accident causation and safety solution. Now question may come as what exactly the significant rules for accident causations are. So when we are doing the analysis, we found out that some of the maintenance activities are happening, some of the incidents are happening during the maintenance activities. Or we found that during shift A in winter season, incidents are like injury or near misses are more. So these are some of the interesting pattern we found out when we analyze the data. Then we found out that, okay, this is the pattern we are following, this kind of data we can study. So collect those data and see that how exactly we can model those kind of accident scenario in a virtual reality environment, so that the people can be trained in this virtual reality environment. They can be trained, and further when they will go to, like, after that when they will go to that workplace, they can avoid this kind of accidents. So this kind of data can be fed to traditional accident causation model, provided that traditional accident causation model will be mapped with safety ideology and technological intervention. That means virtual reality. So that's why it is virtual reality based accident causation model. Now we have like transform it to the traditional one into virtual reality based accident causation model. So some experimental analysis has to be done and VR simulation. So in the experimental analysis, what we can do is some of the accident path elements we can find out. What are the accident path elements, hazardous elements, initiating mechanism, this kind of thing we can find out in this accident path elements. Now, why exactly we are saying it as experimental analysis? Because when we are performing some of the experiments in the virtual reality environment, we found that it may so happen that all the operators are not comfortable with getting trained in this virtual reality environment, because it is having some drawbacks also, like you have to use a maximum up to 30 minutes or 45 minutes depending on the person's behavior, how exactly he is behaving inside the head-mounted display and all. So when we did some experimental analysis, we considered this kind of simulation sickness, system usability, then presence. This kind of factors also we took into consideration. That is, what is system usability? How you are comfortable? How comfortable you are when you are actually operating inside the virtual reality environment. Then what is simulation sickness? If you are feeling some sickness and all when you are doing the simulation and all, then we can identify that thing and we can eradicate that thing also. Then next page is like how exactly the presence. Presence means how exactly you're feeling that, okay, you are inside the working environment. You're feeling each and everything, whatever is there in the workplace, it is exactly similar. How realistic the environment is. So that exactly we can find out with respect to some experimental analysis. So this experimental analysis will tell you that. Then you can go for the VR simulation and you can do some accident path recreation and all. Then next we can come to this, that is the training simulator, which we have already created at the at our lab, SAVR lab at IIT Kharagpur. So this training simulator which we developed, in that training simulator we did two kind of thing. One is safety training and second part is user efficacy improvement. Now, what is safety training? You can like easily it is understood that hazard recognition and hazard avoidance. Now, what exactly this user efficacy improvement is? Then how exactly that person is getting acquainted with the workplace? How exactly that person is getting acquainted with this SOP acquaintance? I still remember when we were doing the experimental analysis, first we subjected some of the operators to standard operating procedures they will follow when they will go to workplace. Suppose there is a crane operator. What they will do first, they will go inside the crane cabin. They will see whether all the control panels are proper or not, whether the AC is on, whether the levers are working or not, whether the emergency switch is working or not, whether the anti-collision hooter is working or not. This kind of thing they have to first identify. That means what? Standard operating procedure acquaintance, whether they're acquainted with all the standard operating procedures or not. Then workplace acquaintance, whether they're seeing whatever they're seeing in the virtual environment, is it the exact replica of the workplace they're working in? If it is not, then there is no point of training them. So we have to give the exact replica or exact workplace when they're working. Then only the user efficacy will improve. That's why this both point we address. Then we we found out some of the interventions, design of interventions, prioritization interventions, and optimization interventions. It is not you cannot recommend each and every interventions that need to be adopted. Some of the approaches you have to take into consideration, where some of the interventions cannot be it cannot be deployed at the workplace. So that's why we have to prioritize some of the intervention, and some of the optimized intervention we can go for with respect to the safety training. Yeah, so the next slide. So So for this is we started with decision support system. I showed you in the last slide. So it's basically I'm not going in detail of this decision support system. What I can tell from here is we have done two kinds of analysis here. One is visual analytics, which you can see in the top part, incident distribution, year and month analysis, shift and day analysis, and all. So I'm seeing any trends and patterns. If yes, then identify the rules. Then if I'm not seeing any trends and patterns, what we can do, we can go for some further exploratory analysis. As we are talking about data analysis, so we are doing some statistical, we are using some statistical method like multiple corresponding analysis, principal component analysis to find out that is there any significant causal inference we can find out. If we are finding out some causal inference, yes, find out the rules and go ahead. These rules will help us to identify the accident path elements which we can subsequently use for this, which we use for VR based modeling and simulation. Next. Yeah, so that slide was completely about categorical data. As in the previous slide I told you, we dealt with categorical and numerical data both. We have not dealt with the text data. So when we are dealing with the continuous data, because we are having risk score also. Risk score is having numeric score. So how exactly we are going to deal with? So suppose the categorical data we are having, suppose shift we are having, what kind of causes, primary causes we are having. So those kind of data are categorical data. But if we are having some numerical data, risk score, now what to do? So what we can do, transform this continuous data into categorical data, convert everything into categories, then you apply the same technique that I showed you in the previous one. You can go for visual analytics, you can go for some statistical analysis. So for this transformation and all, some fuzzy based techniques you can go for, where fuzzy based techniques are rough set theory you can use, where exactly you can transform the data, like continuous data, into categorical data, and simple like one standard data you can use for further analysis and all. Yes, and next. So this is the most important one, like how exactly after getting the data what we have to do and all. So this is the steps for VR based accident causation modeling. First, we have segmented it into three parts. First is virtual prototype based modeling and simulation, hazard recognition, hazard avoidance training. So first we acquired some modeling inputs with respect to photographies, 2D drawings, videography, and laser scanning. Then some digital mockup done, 3D models of component, texturing of component, and environmental development. Then simulation, how exactly like simulation, when you're doing with simulation, we have to take care of the collision and all. What are the standard operating procedure? Whether there should be some collision. Like I told you, anti-collision hooters are there at the workplace. How exactly I will take that factor into consideration. So simulation will help you in this. Then the next part is identification of hazard. So identification of hazard will happen in two ways. One is design, second is operation and maintenance. In design level also, you can identify some of the unsafe conditions at the workplace. In operation and maintenance level also, you can identify some of the unsafe practices that is followed at the workplace, so that training can happen with respect to design unsafe condition, training can happen with respect to unsafe practices. So accident scenario recreation, mitigation approach, and training safe practices. So this is how like three segments we have made, how exactly virtual reality can address this issue of accident causation modeling. And yeah, next, Sudhir. And finally, we are talking about prevention, accident causation and prevention. So how exactly this prevention will happen? So whatever strategies we will identify, two factors we have to take into consideration always: ease of intervention, cost of intervention. So the trade-off between ease of intervention and cost of intervention will tell you that which interventions can be deployed at the workplace so that it will be beneficial for the workers, for the organizations. So it's a product. If you match with product life cycle, so it can go with product life cycle will start with business concept, designing, building, operation and maintenance, decommissioning. So moving safety and prevention to upstream of life cycle process. So like first part you can say it as prevention through design, that is PTD. Second part you can say that redesigning and retrofitting. Like if there are some changes needed, you can address those changes by redesigning or retrofitting. So that is why it is called as prevention through design or redesigning process. So some of the interventions I have mentioned here clearly: axiomatic design, bow-tie tool, virtual reality, then safety function deployment also you can take into consideration, some of the reactive and proactive measures, what is exactly benchmarking for your organization, what is your company's vision. So looking into company's vision, we can actually look into this reactive and proactive strategies. Next. Yeah, this is what I was telling, like house of safety, this preventive strategies and all. So I will not go in this detail and all. This idea actually was implemented, was taken from house of quality. As you all are aware of this house of quality, in house of quality we will have uh, customer requirements, consumer attributes, functional requirements and all. So same things we dealt with respect to safety, like what are the hazards, what are the relation between hazards and what are the tasks we are performing, create the relation, find out the relationship matrix, put this data into second part, that is initiating mechanism and hazards and initiating mechanism, then again initiating mechanism and prevention strategies. Then finally we can find out as which are like which preventive strategies we can go for. So we opt for some capital budgeting method where we consider both financial aspect and non-financial aspect. That's why it is we use some 0-1 multi-dimensional knapsack model for this kind of approach and all. So basically house of safety is like you can find out systematically what is the relation, correlation matrix and all. Task hazard, hazard initiating mechanism, hazard initiating mechanism, and what are the intervention strategies that we can adopt. Okay, yeah, next. So this is one of the case study. We will go through it quickly. We did this analysis. So I just want to, this numbers and figures doesn't matter here. Just I want to show you that how exactly visual analysis you can do. I told you like we can go for some visual analysis, we can go for some exploratory analysis. So you can see year-wise analysis, shift-wise analysis, activity-wise analysis, day-wise analysis, month potential impact-wise analysis. So this is how we did some of the visual analytics stuff we handled. Next, I will show you the exploratory part. Yeah, next topic. See, I was talking about this. Exploratory analysis will give you some of the rules. What are the safety rules and all? So one of the safety rules is in shift A, during maintenance activities, slip, trip, fall are the main reason for first aid incidents. And it is having risk as medium, injury risk medium, equipment risk medium, reputation risk high. So this kind of rule we can get. After getting this kind of rule, what we can do, find out the events leading to accident, create the accident scenarios in the virtual environment, train the operator for this kind of scenarios. So this is what will help us, that analytics part will help us. Next, yes, Sobi. So some of the figures, how we did the analysis and all. This is one of the integrated steel plant where we went and took the data collection, time motion study. We want to see that how exactly like what exactly time they are taking for movement and all. The next, modeling and simulation, how we model the different components of at the workplaces. Yeah, next. This is the complete workplace environment we designed for training and all. It is the exact replica of the workplace we studied. So we created the exact replica. 200 meter or 160 meter was the bay length. Exact 160 meter bay length was created. Each and every component was up to the scale. That means whatever the design is there for that particular component, same design aspect we have taken into consideration up to the scale. Then next, yeah, some of the hazard recognition. You can see one ladle is falling when you are putting that in the caster and all, turret and all. Then misalignment of the ladle also when we are one of the operator when he was doing the training, he like his hook was misaligned and this kind of accident scenario happened. Yeah, next. Safety training inside our lab. You can see two ways. Just I wanted to show you that bottom one is desktop based training, top one is HMD based training. You can see the person is wearing head mounted display. So that is head mounted display he's wearing and he is getting trained. This is VR based training or HMD based training. This is desktop based training. Yeah, next. So now what exactly future scope is lying still in this domain and all. So still we have like some of the text data, how exactly text data can be included in this categorical and numerical data and which can help us to generate more rules. Then decision support system needs to be developed with respect to artificial intelligence and safety analytics from real-time safety data analysis and all. Then how exactly 4D environments is created? Now this particular research is going on in VR domain and all. 4D means we will include the time domain now. So how exactly time domain will come into the picture and 4D environments can be created, and we can go with the we can go with this virtual reality environment and all. Then this research strongly recommends that intervention strategies like prevention through design is a need of the hour now. Then industry 4.0 techniques like cloud computing, IoT, then augmented reality, mixed reality, smart manufacturing can be actually explored. And finally, some conceptual development has to be done, like physical simulator has to be created, and those physical simulator should be having those conceptual understanding of this data analytics and VR-based accident causation model, which will give an edge to the operators in terms of safety. Yeah, that's all. I'm open to questions. Thank you so much for the opportunity, sir. I'm just 10 minutes I took extra.
Yeah, thank you, Dr. Dalma Patro. The presentation was very interesting, insightful, and we have many questions in the chat box. I'll take one by one.
Yes.
So, our first question is, how augmented reality systems can be used for accident causation analysis, as they offer real-time and on-site operation? We do not have to build the whole site from scratch. Please
Yes,
provide
correct.
some guidelines on that topic.
Yeah. So a nice question. Thank you for the question, Evan. Nowadays we are working in this augmented reality part and all. So what exactly is differentiating this virtual reality and augmented reality? Virtual reality is not having see-through display. Augmented reality is having the see-through display. That is the clear-cut differentiation between this augmented reality. So when we are talking about the see-through display, which we were not having in this virtual reality, the immersiveness and the interactiveness in augmented reality is increasing. That's why when we are talking about augmented reality, mixed reality, the level of realism is actually increasing. Okay, so for that reason, as per your question, how exactly you are going to handle this thing and all. So directly I can say you some of the latest techniques that is being used. One is laser scanning. You don't have to go for modeling and all, whatever time consuming modeling and simulation you don't have to do. Take a laser scanning equipment, place at the workplace. You can do the laser scanning and take up the complete laser scanner point clouds and all. You can develop your model in your system and all, provided if you're having augmented reality devices, directly you can like some whatever changes you want to do, directly you can interact with the changes, design changes, models, and you can do some changes. And as far as training, till now it is seen that in research domain and all, augmented reality is providing more realistic experience as compared to VR based experience. This is what the research is saying, and this is what the current trend is going. But it is I'm not saying that it is like VR can be discarded and all, but augmented reality is having edge over the VR because of the see-through experience and all. Yeah, Asis.
Thank you. Thank you. So, our next question is, what is the difference between static and dynamic fault tree analysis?
That's what I told. Like time dependent failure, we are not considering in this accident causation model or fault tree analysis, whatever you say. So time dependency, when we are considering in this fault tree, that is actually the dynamic fault tree analysis. Right? When we are analyzing one event from T0 to 2T, that means it may so happen that some discrete events I will create. T is equal to 0, T is equal to 1, T is equal to 2, up to T is equal to capital T. So each and every events can be modeled in the dynamic fault tree, and then that can be separately addressed. That thing was lacking in static accident causation model, because for a particular time domain, this is the time domain, this is the accident that happened. There is no real-time data we are getting. This is the accident that happened. What are the causes? Model the what are the causes? What are the events leading to accidents? Then we have to go for fault tree analysis. But in the dynamic fault tree, real-time data you can capture, model, do your fault tree analysis. Yeah.
Thank you. Thank you. So, our next question is, suppose I am training a worker in maintenance work using VR platform. However, in a real life situation, while the worker is actually doing the maintenance work, the mentality or mental load of the worker will be different. So how
Yes.
do you differentiate while training in VR?
Okay, so the mental workload will be different. Yeah, definitely. So it may so happen that if I'll say if a person is doing a maintenance work at a height of 60 feet and all, he must be wearing this harness and going to the work, like going to that height, and he should be doing that thing. So he'll be definitely having this fear of going to that height and doing this work and all. That's why I told you repeatedly, I focus repeatedly that VR is having risk-free, repetitive training platform. That what will happen, that kind of training cannot be provided to that particular maintenance worker whenever it is needed. Because in any training center, like real-time workplace scenario, you cannot provide. Because training center will not be having that kind of stuff. What you can do instead, you can create the environment, tell this maintenance worker this is the exact replica of the workplace. That means what I'm using his, like I'm feeding his in his brain that this is the scenario he is going to face in the actual workplace. Then he will be confident when he will be going for maintenance, because he has seen this thing already. He has seen this thing already. When he will be going to that place, that confidence will be more, because that we have seen and verified in the experimental analysis also. Yeah, Asis.
Yes, yes. So I'm taking one more question. The last question is a big one. So I'm just reading this one. My question is that we run a plant and we have collected numerous hazards through hazard identification systems.
Yes.
Suppose one hazard is checked plate. Suppose one hazard is checked plate corroded. Okay, so several hazards came on that plate which is corroded. We changed this plate, but later on accident occurred due to collapse of that plate, checkered plate, and fall from height. So how to devise a procedure so that hazards can give direction to the company where to check the risk?
Okay. So this question is a very good question, which we actually develop this kind of scenario in the virtuality environment for our, because this kind of scenario we came across, like in this checkered plate and all, what will happen is sometimes this plates will be corroded, and sometimes you will find out that due to substandard condition of the checkered plate, these accidents are happening. I think that is the question he was asking. So if there are some corrosion, you replace this checkered plate with something, and new plate, and you can start. But each and every way, like in if you are finding out that the checkered plate is a hazardous element, so what we can do, identify all the possible ways this checkered plate can actually create accidents. So what exactly we have to do here? All the events, possible events leading to that accidents because of that checkered plate can be identified beforehand. Then what we can do, like if we are going for risk analysis, then what we can do, create a similar kind of working environment, take this checkered plate into consideration, create all the possible accident scenarios that can happen, give the risk priority score or risk prioritization scheme you create, and tell your authority that in this manner the risk can be prioritized if checkered plate will be having this kind of different conditions. So as per that, whatever as per your risk prioritization and all, whatever you are finding out, then you do your maintenance procedure, and then you go for any preventive strategies that can be adopted for your particular workplace and all. Yeah, that will be my answer to this.
Yeah, thank you, Dr. Dharma Patro. So now I would request Professor Krishna to formally provide vote of thanks to our expert speaker.
Thank you, Ashish. When you're all talking, calling Kranti by full name, I'm confused. Are you calling somebody else? So he is very popularly known as Kranti. Of course, now Dr. Kranti. So thank you, Kranti, for excellent presentation. As you told in the beginning itself, you'll make it as simple as possible so that a common man can understand. And you have really succeeded in doing so. You have made the accident causation, right from the accident causation models to future scope.
Yes, sir.
as understandable to all the people. For that, thank you very much.
Thank you, sir.
And as Professor Maiti told, you're the first person in IIT Kharagpur who worked in this field and successfully worked in this field. Your seed of foundation is taking up in the right shape.
Yes, sir.
Very happy to tell you with this IIT work, some of the organizations are starting their own VR-based training in their own organizations, big organizations. They have understood the benefit of it. Very good. And when you mentioned the risk-free training using VR, it's a very, very powerful word which you have really told. That is the gist of VR. Without taking the risk, you can feel what the risk will happen.
Yes, sir.
So organizations will take this understood this powerful tool of VR, and they want to put for safety purposes to understand to inject the different types of risk in the existing scenario and tell people this is what it can happen.
Yes, sir.
Especially many of the risks may not come true, but if it comes true, it will be disaster. So VR will help a great way. And finally, Dr. Kranti, I can tell you, you have proved yourself to be a very good safety specialist. So you touch all practical aspects, theoretical aspects. Professor Maiti must be very happy to see you in this passion. Thank you very much.
Thank you, sir.
And the moderators help to make this successful in spite of some technical problems. So that is what is IIT Kharagpur. Good. And your association will be with us. And
Yes.
also the participants, though it is today is Holi, I could see good number of participants.
Yeah.
And all the participants, moderators, and all across the world, I wish them a great Holi. Holi is the festival of colors. Whenever you want to be happy, celebrate, we show colors. So after 2 years of pandemic, first time the Indian community is celebrating Holi. We have also celebrated. Keep celebrating, and we'll meet you next week again. Actually, we thought whether we should keep this session today or not, but we did not want to discontinue this. That's why we have kept, and Kranti, you made it successful. Definitely. Thank you very much. Thank you all. Good night.
Thank you, Kranti. Thank
Thank
you
you, sir.
very much.
Thank you, sir.
Thank you very much, sir.